Welcome to Beekeeping Today Podcast Shorts, your quick dive into the latest buzz in beekeeping.
In 20 minutes or less, we'll bring you one important story, keeping you informed and up to date.
No fluff, no fillers, just the news you need.
Brought to you by Betterbee, your partners in better beekeeping.
Hey everybody, welcome to this Beekeeping Today podcast short on Varroa Treatments. This is a multi-part series covering the different treatment options available to combat this honeybee pest. Each short in the series will cover one specific treatment option. For the series, we've invited Dr. David Peck from Betterbee to join us. In this short, we'll be discussing fluvalinate and coumaphos, otherwise known as Apistan and CheckMite Plus. Hey Becky, hey David.
Hey, how's it going?
It's going, if I can get past these tongue twisters, I'll be fine.
Well, this is true of a lot of miticides, and we might as well just deal with it now. The pronunciations of some of these things are up in the air. When we get to the episode about thymol, we can have a big fight about thymol versus thymol. So don't feel too bad about coumaphos versus coumaphos. You know, I think this will be a really fun one because this is our, I think, only combined episode about two totally different active ingredients. And the reason for that is these are both active ingredients that, for the most part, beekeepers are not going to be reaching for to treat the varroa mites in their hives. But it's really important to talk about them because of the historical background that beekeepers need to understand about what these things are, how they were used, and why they aren't currently being used by most beekeepers.
It's a little bit of beekeeping history because when the mites first came on the scene, there were not a whole array of different products that were available to beekeepers. And so we're kind of going back in time, and we're going to learn a little bit about why we have a lot of products right now available to beekeepers.
why we
right,
have
David?
to have a lot of products. That's exactly right. So yeah, Varroa was first recognized in the United States in 1987, and Apistan strips, the active ingredient in those is a molecule called fluvalinate, was first registered in 1990. Although there's reason to believe that there were some bees that were getting treated with this before 1990, because as soon as they showed up in beekeeping, beekeepers started grabbing whatever they could, whether or not it was legal for them to use it to treat their mites.
I was going to say it was registered for honeybee use in 1990.
That's right. Exactly.
It's been around for a while.
Yeah. And then so Apistan really formed the foundation of mite control for all beekeepers and all beekeeping until there started to be some, shadows lurking off in the distance that grew longer and longer and darker and darker. And that was more and more people talking about using Apistan to kill their varroa mites and finding that it just wasn't killing as many mites as it used to. And that was really beekeeping's first robust taste of watching a parasite develop resistance to the molecules we were trying to use to kill them. So Apistan was no longer effective, and that left beekeepers with few other options. But CheckMite came onto the scene. The active ingredient in that is a molecule called coumaphos. And so they switched from the Apistan strips that were no longer effective to the coumaphos strips, which were very effective. But the problem is that the mites developed resistance to coumaphos even faster than they had developed resistance to Apistan. And so very quickly, we went from having one effective product to one sort of waning product, but a new, savior come in to save the day. And then two products that were, if not ineffective, were certainly a heck of a lot less effective than when beekeepers had first started using them. And neither of them was effective enough to really control mites very well.
And they're both synthetic chemicals, right? They're not organic based.
That's right. These are both engineered molecules that are synthetic pesticides engineered to kill mites. And since varroa mites are mites, and these things were engineered in a lab to be toxic to mites, but not to insects like bees, it meant that they could have a very, very targeted effect. You can put this stuff into the hive, and if a human gets exposed to it, it's not going to have, we're not going to keel over dead. The bees that get exposed to it aren't going to keel over dead. But the problem is those hyper focused targeted molecules are typically going to interact with just one very important varroa protein. And so all the varroa needs to do is change the shape of that protein a little bit, and suddenly those targeted molecules aren't going to work anymore.
And so just to really simplify it for people, if there's a chemical that's very effective with a high efficacy of killing a population of pests, then those survivors, and you can jump in here because your PhD is a lot more new than mine, but those survivors are, you have the potential of those survivors having resistance. And this is where I'm going to have you finish the sentence.
Exactly. So it's basically, we've all seen the ads for the antibacterial soap that kills 99.9% of germs. And then we all sit in our beds staring at the ceiling at night trying to fall asleep going, what happens to the 0.1% that survive? and that's sort of the situation we're dealing with here is that, if I've got a molecule that kills 99.9% of something, then that's fantastic. But if all of the 0.1% that survived because their genes are just a little bit different and it allows them to resist that molecule, then when I go and use the molecule again, I'm not going to kill 99.9%. I might kill 0%. Typically what we see though is that in a population like a bunch of mites on a bunch of bees in a bunch of apiaries, what we see is that over time the effectiveness changes from 99% to 95% to 80% to 60% to 40%. It drops over time as the mite population by and large shifts to being mites that are carrying those genes that make them resistant to the molecule. And so this is the real danger of the mindset that beekeepers sometimes get into of saying, I like this miticide. I know how to use this miticide. Therefore, I'm only going to use this miticide. This is the reason that all integrated pest management recommendations, that all professional bee educators are trying to get everyone to rotate between their miticides. The reason for that is if I rotate my miticides, if I use one molecule that kills 99.9% of the mites, but the 0.1% that are left start reproducing again. Well, if I use that same treatment over and over, that has a pretty decent shot of just losing its effectiveness entirely. But if my next treatment was a totally different molecule, and those resistant mites from chemical 1 are not at all resistant to chemical 2, then I should be able to bounce back and forth between chemical 1 and chemical 2 for a good long while, sort of juggle them, and I have to keep the mites on their toes. They don't get the ability to just focus all of their population's gene change in that one direction to be resistant to that one chemical. I think the reason beekeepers are so insistent to each other about rotating these chemicals is that we've seen exactly what happens when we don't. When we depend upon just one thing, we wind up getting ourselves in trouble.
Such as the instance here with Apistan and CheckMite Plus for the trade names, but for fluvalinate,
right, exactly,
and coumaphos. So we listed them here in the shorts. Should beekeepers even consider using either of those chemicals or products at this time?
I would say probably for the most part, no. And the reason for that, there's a couple of reasons. Number one, we know that there are some mite populations that seem to have over time lost their resistance. So you might be able to kill your mites with these things. But for the most part, by and large, mites are still resistant to both of these chemicals. So it's not going to be effective. It's a waste of your money. It's a waste of your time. Your bees aren't going to be healthy at the results of this, at the end of the treatment. But then the other problem is we know that both of these molecules, tau fluvalinate and coumaphos, are both really, really happy to dissolve into beeswax. They're fat soluble, and so they dissolve right into that wax comb. And what that means is that when I pull the plastic strips that are saturated with the chemical out of the hive, I haven't really pulled all of the chemical out of the hive because all of those remnants are getting into the comb, and they're going to live there for a long while. It means that brood that are being raised in those exposed combs wind up suffering because they are exposed to low doses of this chemical. It means that varroa mites that get into that hive and have, maybe the beginnings of resistance, maybe they're only partially immune, they are going to be living in an environment that's very lightly saturated with these chemicals. And so you can expect that would really contribute to developing resistance. And so for that reason, both because of the risk of wax contamination and because they just aren't that effective, these are not the first line of defense for almost anybody. That's not to say that there isn't a market for them or that folks aren't using them. When I was doing field research in Madagascar, I actually learned that a lot of Apistan was being sold and used in Madagascar because the Varroa mites there weren't resistant to it. Varroa had gotten there in 2012. I was there, maybe 5 years after that, but the mites were still very effectively controlled with Apistan strips. And so the manufacturer of it was selling it there, and they said, look, your mites might very well evolve resistance. We have to be mindful of comb contamination. You have to cycle your combs more regularly, but this is a cheap, effective miticide that you can use now, and it buys a little bit of time for the world to keep developing better and better and better miticides, which you might have to switch to if this one ever loses its effectiveness.
So, David, I think a lot of people are thinking of we might not be just fighting one mite, but in the future we might have to fight Tropilaelaps. Are either of these chemicals being studied or used against the tropy mite?
Yeah, research has been conducted on these molecules. There's obviously a great effort to figure out every single chemical that will or won't kill tropy mites, so that if they show up here, we have a whole arsenal pointed at them. But the best way to figure out what's effective is to go talk to the beekeepers in Southeast Asia who have been trying to keep their bees alive. And so there are absolutely folks using, not brand name Apistan and CheckMite necessarily, but who are using tau fluvalinate and who are using coumaphos-based miticides to kill Tropilaelaps mites inside of their Apis mellifera colonies. So yes, they can be used. They still have those downsides of wax contamination, and the concern that one has is, how much money can I afford to spend on miticides for my bees? Because we sort of act like if Tropilaelaps shows up, suddenly, things will kick into a high gear and we'll spend all of our time fighting them. But we'll still have Varroa mites. We'll still have to keep them under control as well. And so if these chemicals aren't effective against the Varroa, it may not be that effective to deploy them for the Tropilaelaps if we can find something, hopefully, that's able to kill both of them.
Better.
And just to be clear, neither of these products should be used with honey supers in place.
Absolutely right. Yes, because they're synthetic pesticides and because of the way that their label is written, absolutely you cannot risk, human consumed honey getting exposed to this stuff. So, right, it's only a treatment, even if you are choosing to use them, it's only a treatment that you can use when your bees aren't actively making honey for you.
I feel like we've talked a lot about the negatives, but maybe we should talk a little bit about why they were developed in the first place, or what really. I mean, there's one big pro, I think, around temperature, correct? As far as application.
Right? Yeah, they're very permissive about temperature, and they, just like the strips that more beekeepers are used to, Apivar strips, which we're not going to get into in this short, but just like other synthetic pesticides inside of these strips, they're gentle on the bees. They're, as long as they work, harsh on the mites. They have very wide temperature ranges at which you can put them into the hive. So there's a lot of things going for them as long as they're able to continue killing your Varroa mites.
I think it seems like these two miticides are really a lesson for what it's like to be a small industry needing to develop pest control products, and also about the fact that way back when Varroa were here, transmission of viruses weren't on really what we were worried about. And so even though I think scientists and farmers knew about the resistance issue, there wasn't a lot of financial investment in figuring out how to really develop effective IPM strategies until we saw a crisis.
Right. And even when we had the first crisis of Varroa, we, the time and the effort was put in to develop the strips, the Apistan, but then we felt like, great, we've got something that works, so now we don't need to invest any more, right? We didn't have that broader mindset that said, I can't just have this one chemical to fight against these pests. I need to build up almost instantaneously a library of options to fight against Varroa.
Right.